Good afternoon, everyone. Thank you for taking the time out to come and watch this and sit and listen to me talk about our Raptor, our fire tube boiler. We're going to go over setup, piping, troubleshooting, the LP conversion, and setting it up for altitude. In the handout section, you guys should see this little white box on your right-hand side. You should be able to see the handout section. In there, I have the LP conversion instructions for the Raptor wall hung manual, and the 320 and 399 manual. They're both locked in. They're both locked in there, and we'll be showing you guys. Get a recording of this at the end. Should get emailed to you, and we'll be showing 3 videos through. I'll share through my screen. One on the altitude setup for the control, central heat setup, and the outdoor reset curve setup. Those videos will also be able to be found at a later date on our YouTube channel. Our YouTube channels, if you search Crown Boiler on YouTube, you'll find our YouTube channel, and we'll be periodically posting videos on there throughout the time. This will also be up on there. If you have any questions or anything, you can feel free to fill them out on the questionnaire. Either myself or Lee will get back to you with them. If I'm moving too fast or anything, feel free to tell me to slow down. But this normally runs, if I'm doing it in person, about hour and a half, hour and 40 minutes. We'll see how long it takes with this. Doing it on the video platform is a little bit different. First piece up is the Raptor. All the features that go along with it. It is a stainless steel fire tube heat exchanger. Very low pressure drop. All the boilers from 80,000, 85,000, and 399,000 are using the AIC heat exchanger. They're all going to be 95% efficient and have a full 10-to-1 turn down. Across the board, there's going to be a 12-year heat exchanger warranty and a 5-year components warranty. Components are going to be sensors, the control, the display, fan, gas valve, igniter, flame sensor, so on and so on. Be all covered under the 5-year parts warranty. There is a combi available. The combi is still 5-to-1. It's going to be 5-to-1. There's only one size. It's 155,000 BTUs. The mixing valve and the piping kit all come with it for piping the domestic side. We'll talk about the combi briefly at the very end of this. And one of the key features with it is its easy to use interface, full digital touchscreen, and you'll see that in the videos they'll be following. Very, very intuitive. We're proud to say that this product is assembled in Lancaster, Pennsylvania. Our parts may be sourced from around the world, but it is fully assembled here in the United States, right in beautiful Lancaster. Any of you guys that came out before with Jim may have got to see the facility. And another key part with the product is it goes through a rigorous testing. When it gets out to you, I know you guys aren't exactly all natural gas and sea level, but natural gas and sea level, I'm 99% sure when you give this product water, fuel, and power and apply a call for heat, that it will fire off. The next portion we're going to go over is the gas piping requirements. You're going to need to size the gas piping in accordance with the BTU load, but there's going to be some min maxes for the inches of water column for these products to run correctly. Real life story. I've run into issues with these. Only seeing the static pressure. Just putting my manometer on there and seeing it hold at 5.5 inches of water column and thinking, okay, why isn't this boiler firing? We also want to double check the dynamic pressure. Turn other fixtures on. The case in point that I was speaking of, whenever the boiler would go to light, the gas line was dropping into a negative. I was dropping down to like negative 2.4 inches of water column. There was a faulty regulator and a bad meter in the system leading to that. Minimum water inches of water column for LP is going to be 8, and natural gas is going to be 4. Too high of gas pressure also results in some problems too. Gas pressure that's too high, you line up with some whistling and weird combustion noises. Also, if there is an inline regulator, we want to try and keep that inline regulator approximately 10 feet away from the boiler, so you don't wind up with any of the reverberation from the regulator. The 320, 399, you're going to be able to do about 3.5 inches of water column. Is going to be the minimum that those products will run with. And again, it's a 400,000 BTU gas appliance. We're going to need to size it accordingly, size the gas lines properly for the unit. Another thing with CSST, if we bring the CSST right to the products with no straight pipe, when they're in their higher firing ranges, we can get some whistling. Again, that gas valve, the negative pressure gas valves are going to draw in the gas as fast as possible, and you will get a harmonic sound out of the CSST. The Raptors do not ship with circulators. The circulators are going to need to be sized based upon the delta T that you're looking to run for the boiler. On the wall hung boilers, the 0010 will work for majority of the products. And again, the circulators are for the near boiler piping. It is in the manual, but it's not recommended to direct connect these products directly to the heating system. If you're going to direct connect them to the heating system, you're going to need to size the circulator to overcome both the pressure drop of the heat exchanger and the pressure drop of the system. So a 007 may not be the circulator to use if you're going to be direct connecting the unit. On the wall hung products, on the residential Raptors, we have several piping options with them. You can do your supply and return off of the bottom. You can do your supply and return off of the top. You can do top, bottom, same thing again, or both, or all out of the top. There also is, I don't have the picture in it here, you can do your heating system off of the top of the unit, and you can do your domestic hot water tank off the bottom of the unit. You just have to make sure that you have supply, return, not supply, not return. It will immediately go off on modulation errors. They are labeled, the return and the supply. There are stickers attached to the jackets explaining which one's which. This is showing standard piping of the product with an indirect water heater. The indirect can be either piped inside the boiler loop, as this one is, or it can be added as a second zone for the system. We would just have to, in the pump selection, turn the boiler pump off to allow the units to run. The unit does not come with a low water cutoff. There's a plug inside of the unit, and the harness is going to be attached to the supply sensor. You'll see a bundle with red and gray wires, and in that bundle will be the blue and yellow harness for the low water cutoff. Any 4-pin low water cutoff, whether it be hydro level, guard dog, Takeo, any of those will work as long as it's a 24-volt 4-pin low water cutoff. You pull the brass plug out and screw the low water cutoff into the fitting. The larger boilers, the Raptor 320 and 399, they're going to require a little bit of a larger pump. They're moving more BTUs out of them. Again, the pumps that are listed here are for the near boiler piping. If they're going to be direct connected, we would need to size accordingly for both the boiler and for the system. I talk a lot about in my Hydronics 101 training about running a 30-degree delta T on condensing products. And that's basically where we want to see these things live the majority of the time, is with that 30-degree delta T. So we're able to get them to condense more. So 0010 or 0014 will be absolutely fine for the 320, 399, or the Grundfos equivalents, the UPS 2699, it'll be on speed 2. And the UPS 2699 for the 399 would be on speed 3. So there, one pump at different speeds will work for both of the boilers. The 399 and 320 do not come with a port for the low water cutoff. We show where they would be optionally piped, and if you were using any of the CSD1 for them, the manual reset high limits shows where they would like them to be piped. There is a harness kit for the low water cutoff, and it will plug into the Raptor's PCB board. And again, here we go, laying out piping for the 320, 390, 399. And this drawing is showing the indirect tank piped in the system as a separate zone. Reason why I'm using two different pictures for the boilers is showing the different piping options that we can offer. So the electrical connections, the wall hung products are going to have, on the left-hand side of the boiler facing it, you're going to have your high voltage PCB. Low voltage are going to be on the right-hand side. The floor-mounted 320, 399 are going to have your connections right on top of one another. And this front panel door opens up. Whereas when you take the jacketing off of the wall hung, you have direct access to the heat exchanger and all of the harnesses. Your 120 volt connections are going to all be labeled and going to be fuse protected. The spare fuse comes with them, and there's also be an envelope shipped with them that'll have the spare fuse. If you're not using one of the pumps, don't worry about it. Just don't wire it. And if you're using a zone panel for domestic hot water priority or anything else, there's wiring diagrams showing how to get them to get full priority if you're not using our Sage panel. Your low voltage connections are going to be fuse protected. There is a common for using a 3-wire thermostat wire, 3-wire thermostat, such as the Nest, the Ecobee, the Lyric. It is available there. One of the common mistakes I've made wiring these is I tend to wire the common and the aquastat together, and I instantly pop that low voltage fuse. So if you go to first turn the boiler on and give it a call and energize it, and the screen goes blank and the fan runs to high speed, double check your low voltage wiring here and double check your low voltage fuse. The boilers are going to have 3 plugs on the front of them, 3 plugs that'll accept Cat 5 cable. One will be for the Aviracom. If you were using the Sage panel, this is where the Sage panel would plug into. The other 2 are going to be your Mobis ports, which will be for boiler-to-boiler communication. With the onboard controls for these products, we can link up to 8 of them together with no extra controls. It can be done via Cat 5 cable or 3-wire thermostat wire, -V, B, or A. In order to do multiple boilers, you would need to wire the header sensor in. If you don't have the header sensor, it will not allow you to enable a master. So setting up the boiler and the control. When you first turn this product on, this is the screen you're going to be greeted with. It's going to have your status, your detail, help, and adjust. It'll say boiler. If you're using a combi, it'll say boiler/combi. This right here will give you your call for heat or what the boiler is doing. Currently, there's no call for heat. It's in standby. If it was responding to heat, it would say central heat or domestic hot water. Energy save on. That will only show up if you're using the outdoor sensor. The unit comes looking for the outdoor sensor. Max efficiency on. This one will come and go. The max efficiency on only shows up when we have return water temperatures under 130 degrees. 130 degrees or lower. When the boiler is going to be condensing is when that shows up. And while we're at right here, I'm gonna pause for a second and show a video of how to do the central heat setup.
Yeah.
In today's video, we are going to cover adjusting the central heating set point. In today's video, we are going to cover adjusting the central heating set point in the Velocity Boiler Works condensing line. When the boiler is first energized, we will be greeted by boiler's home screen. Boiler's home screen is going to say boiler or/combi, and that's combi at the top. Air and supply temperature, firing rate, the heating demand, whether it's responding to a call for central heat or domestic hot water. Energy save on, going to let us know that the outdoor sensor is hooked up and it's looking for it. And max efficiency on will come and go. That will only be present when the return water temperature is under 130 degrees. So to get into adjust the central heating set points, we're going to press adjust.
Hey, John, the video's not moving.
Video's what?
It's a stagnant screen. We can hear the audio, but no video.
Create a risk of property damage, injury, or death. Meaning if we adjust it outside the recommended settings, we could have some. You see it now? Problems. We're going to press adjust.
Now you can. You may want to start it over, please.
We're greeted by and max efficiency on will come and go. That will only be present when the return water temperature is under 130 degrees. So to get into adjust the central heating set points, we're going to press adjust. When the adjust button is pressed, it'll bring you to this screen. They'll inform you improper settings, service, create a risk of property damage, injury, or death. Meaning if we adjust it outside the recommended settings, we could have some weird problems. We're going to press adjust. Press that, we're greeted by the login menu. To get into the adjustment mode, we're going to have to enter a password. To do that, we will press login. Once we press login, 5 zeros will show up, and it'll ask us to enter the password. We press the 5 zeros, keyboard shows up, and the password to get in, is going to be 86. 86 will allow you to enter any of our condensing products. Same password across all of the product lines. We do 86 and then enter. And then we're asked to press save, store the password, and then we press adjust. And once we press adjust, it'll bring us into our adjustment menus. There are 4 adjustment menus. In this video, we're only going to see 2 of them. This will be the screen you're originally greeted with, system setup, modulation setup, pump setup, and contractor setup. We're going to press the arrow and move over to the second set of menus. Here, it'll have manual control, auxiliary heat, central heat, and outdoor reset central heat. We're going to press central heat. When that's done, it'll bring you to this screen. factory set point is going to be 180 degrees on all of our fencing products. And it can be adjusted up to 190 and as low as 60. Make the adjustments, we would press the up and down arrows. If there's a line above it or it's flashing, the setting has not been saved. In order to save and store the setting, we'd have to press the check button. Once the check button is pressed, the line will disappear and that is now stored. The new set point for this boiler is 170 degrees. Our diff above is when the burner will turn off. Our set point's 170, the burner will turn off at 180, 10 degrees above 170. Our diff below is when the burner will turn back on. Turns off at 180, 5 degrees below 170 is 165. The burner will turn back on at 165. Next menu in here is going to be our response time. And this is going to be how quickly the boiler starts to modulate. We turn it down to 1, the boiler's not going to modulate very quickly. It's staying on fire. It's not going to react to the system very, very quick. And move it all the way up to 5, it's going to react really, really quickly. We may wind up overshooting our set points. 3 seems to be the best setting for it, and that is where it is left at the factory. You can play with it as you need or as you feel. But 3 is primarily the best setting for it. Our low fire hold time. Now this is going to be a very important setting. Low fire hold allows the boiler to see what's going on in the system before releasing and ramping up the burner. If it ramps up too quickly, it can result in short cycling. We really don't want these units to short cycling. Short cycle causes early component failure, makes them less efficient. So this is adjustable from 0 to 3 minutes. And we can adjust that, and it'll hold the boiler in this lowest firing rate to see what's going on. As soon as it's done, it will release and go to where it needs to be. The last menu in here is going to be our modulation sensor. Out of the box, it's going to be looking for the supply sensor. There is an optional header sensor that can be installed on the boiler where it would monitor the header temperature and it would modulate off of the header temperature. If you're doing multiple boilers, and that would be covered in another video, the header sensor is required. Okay. Thank you guys for going through there. If you have any questions, type them in and Lee and I will get them answered to you. I figured going through the video would be the easiest way to show how to set the central heat set points. I can go through my slides, which are on here. What we're able to change as far as adjusting the outdoor calibration. This white has the asterisk next to it is only on the Phantom X on the commercial products where we can adjust the sensor calibrations. Many of the residential products we can't do that. So the changeable settings, again, as we go through, what we're able to adjust in there, our temperature units, if we wanted to change it to Celsius, our outdoor sensor source. It's going to come set up wired. Looking for a wired sensor. There is a Honeywell option for a wireless sensor. I'm not sure offhand of the model number for it, of the part number for it. I knew the old Honeywell part number, but it doesn't cross-reference over to the new Residio part number. The anti-short cycle time is also, I have to put an asterisk on there, is also on the commercial boilers. Terry, what is the wiring pin out for the Cat5 cable to hook up multiple oils together? Is there a standard network patch cable wiring? It'll be a standard Cat5 cable. There is a wiring as far as which wires go where. If you're making your own plugs in the manual. It does not matter whether it goes in the top or the bottom. It will continue on as basically as you go down the line. The master boiler, it could be at the top or it could be at the bottom. If you were doing, got it. If you were doing multiple boilers with it, it doesn't matter which one you use. It could be master at the top, slave at the bottom, so on and so on. They're both going to do the same thing. Or if you're doing the 3-wire thermostat wire, you would just daisy chain them all together. We'll get back to it. Again, any questions, feel free to stop me and I'll work down through it. Manual control. This is really only going to be used for setting up the boiler, for doing our combustion testing. One of the things we want to do when we're doing our combustion testing, we need to be able to dissipate heat. We're going to need to have this boiler run in high fire at its max BTU range for up to 15 minutes. In some cases, we're just going to open up the auto feed and we're going to just run cold water through the boiler. Especially when we're doing our LP conversion kit, doing our LP testing, we're double checking our combustion as we change it for altitude. We need to throw a lot of heat out. Low fire is then tested after we get the high fire dialed in. And that'll be what we're talking about right now, getting these things dialed in. This is the detail of the gas valve. Right here is our offset. Right here is our throttle screw. We want to make all the big adjustments on this throttle screw. If you go through and you read the instructions, it's going to tell you to move this throttle screw in like 1/4 inch to 1/8 inch turns. Move it a little bit at a time. That throttle screw is not as sensitive as the manual makes it out to be. If you get the pleasure of having me come out and visit you to do one of the startups, it's usually like a half to a full turn is where I start turning with that. On the other hand, the offset regulator, you barely want to move that. A 1/8 of a turn, or barely even an 1/8 of a turn, you get a lot of movement out of it. If you move it too much, the gas valve gets way out of whack and we usually lose the low fire feature. Unfortunately, when that happens, that's a new gas valve. In some cases, I've had contractors get confused and go to turn the regulator to bottom it out for the fuel adjustments. When that's done, the little diaphragm in here pops and the boiler will not run in low fire, and your high fire combustion numbers will be all over the place. You won't be able to get them to dial in. Right here is our rectifier module. And on the rectifier module, on the side right here where the laser pointer is, there's a wonderful little switch there. And that switch can often be turned in the off position if we're checking our inlet gas pressure. We got to take our hoses back off. We'll bump that switch in the off position and it'll give you the belief that the gas valve is defective. The gas valve, you'll test here, you'll get 24 volts going to it and the gas valve will not open. That switch needs to be in the I position, not in the O position. There's little letters written on the side of it. That is usually one of the initial startup problems. That or the tube to the air proving switch. That's sometimes is bumped off, especially during the LP conversions. And there's a screw in here that needs to get backed out 5 turns. In some of the products, some of the newer builds, we've stopped putting that screw in. That screw is fully removed. You do not need it to run. So the gas valve on the 270 and the 399 is going to be slightly different. We're not going to have the regulator with the switch. It's going to be a regulator that's screwed to it. There is no on-off switch for it. Your inlet tap's going to be down here. Your throttle screw is going to be moved over a little bit, and your offset regulator is still going to be in that same area. Outlet tapping is still going to go to your air proofing switch. Same thing is going to be with this. This is not as sensitive as the instructions make it out to be. Half turn to a full turn. Wait about 25-30 seconds for the analyzer to adjust, see where it's falling out, and then move it into place. In some rare occasions when we're setting these up, when we can't get high fire to fall into place, we get high fire as close as possible, drop down in the low fire, dial in the low fire, and then go back up into high fire, and you'll notice that now we're able to get the ranges out of it. It's just changing the offset regulators set points. So natural gas combustion readings, and then these are all at sea level. Won't really mean much for you. Sorry, I was reading a question, and I believe it's one that I answered. Yep. So these ones won't really mean much to you. These are all natural gas at sea level. The ones that'll mean stuff for you are going to be here. These are all natural gas altitude settings. This is right out of the I&O manual. It's basically, you're looking 9.7 to 10 is going to be our ranges for our CO2 percentages. One thing I can say, don't chase your tail. If you're setting up a Raptor 85 and we're sitting at like 10.2 here, we're fairly good. Most of our analyzers are going to have a 0.5 plus or minus. Usually start to worry about our CO2 parts per million. It'll usually fall on natural gas between like the 45 to 90 range when it's in range. 40 to 90 parts per million is around normal for the combustion. And our D rate for the products, 1% per thousand feet. The 270 is going to be almost 4% per thousand feet for the derations. When you do derate with the control, and we'll get into, I'll show you what you're doing with the control will automatically give you its new BTU firing rate. And we're going to go through a video showing the altitude adjustments on the control. In this training, we're going to cover the Sage 2.3 control system, In this training, we're going to cover the Sage 2.3 control system and setting the product up for altitude and proper fuel. The home screen on all our boilers is going to look like this. You're going to have your status, your detail, your help, your adjust. It'll say boiler, current supply temperature, and the BTUs. In this training, we're going to be going over the adjustment menu. To enter the adjustment menu, we're going to press adjust. Once you press adjust, this screen will show up, informing you improper settings or service, there was property damage, injury, or death. If you were to press service contact, you would enter in your service contact information, your phone number, company name, etc. We're going to press adjust. When we press adjust, it's going to ask you to log into the adjustment mode of the boiler. Currently, there's no access level, meaning you cannot get in to make any changes. So we're going to press login. Once we press login, this screen's going to show up, and we're going to have our 5 zeros. So what we're going to need to do is we're going to press those 5 zeros, and when we do so, our keyboard's going to show up. The password for all of our products, both residential and commercial, is going to be 86. We press 86, enter, and once we press enter, it's going to move over to this screen. So in order for us to get into the adjustment mode, we're going to have to press save. And then we press adjust. Once we press adjust, it brings us to this menu screen. There are 4 other menu screens, and we will cover all of those in a different training. Today, we're going to be focusing on the modulation setup. We would press modulation setup, and it's going to give you the boiler type. This one's a Raptor 155, it's sea level, and it's natural gas. If that's the boiler that we're working on, we will just press confirm and move on to the next menu. But we're going to press adjust. When we press adjust, it's going to bring up this warning. Again, letting you know that the replacement control label must list boiler model exactly. That it's compatible with our 5-to-1 and 10-to-1 boilers, smaller than 270,000 BTUs. The 10-to-1 products go from 80,000 to 205,000. We're going to press adjust, and we'll bring it up to this, bring us to the screen. It tells us the boiler type is a 10-to-1 boiler, 10-to-1 turn down ratio, and 80 to 205,000 BTUs. We will select the model through the arrows, but this is going to give us the outline for our altitude. Sea level, 0 to 2,000 feet. 2001 to 6,000 feet would be 26. 6,7 will be 6,100 to 7,800 feet. 7,0, 7,801 to 10,100 be all of our altitude settings. We would press the up and down arrows to scroll through the boiler model, make and model. This one is showing a Raptor 85,000 BTU boiler. It's at 7,000 feet, and it's natural gas. The natural gas and propane setting will be followed by the sea level designation, then -N or -P. Not every model has a natural or propane setting. They can be found in the I&O manual, which we will cover very shortly. Here it shows a Raptor, same boiler, it's an 85,000 BTU boiler, it's at 7,800 to 10,000 feet, and this one's propane. Making the fuel designation changes the fan speed, sometimes changes the light off rates, changes max fan speed. All that information can be found in the I&O manual in the charts. Here's a list of all the charts for the Raptor series. And we can see sea level, natural gas settings, and sea level propane settings. The only thing that changes is the minimum firing rates and your maximum heat rate. You lose 100 RPMs. You go across the board, all the natural gas ones, all the propane ones. It's basically readjusting the fan speeds. For the most part, the light off rates stay the same for natural and for propane. In some instances, depending if there's any combustion noise or a little bit noise at light off, we will raise it and or lower the light off speeds. That would be done after we dial it in with a combustion analyzer. And the same chart is also found for the Phantom series. If it's blank, we don't have a listing for it. This one's only, the Phantom 80 only has natural, has no propane at altitude. The 100 does have some propane altitudes. The 120 is only good to 6,700 feet. And the 150 goes all the way up, and the 180 will go up if it is an M model. There's that model designation change. Again, all of the LP conversions will be covered in a different training. This is just for setting up the boiler for altitude. If you have any questions, you can reach me at johnm@velocityboilerwork.com. So you guys know how to get a hold of me, because you guys basically have my full attention right now as well. You can get back to screen sharing for you. Guys, have any questions on the setup for the altitude duration? Now, all of the boilers are going to be on the same display, same control, whether it's a Raptor 85 or a Raptor 205, whatever control is on the shelf will work for them. The Sage 2.3 platform that we're using has everything in there. The altitude settings, the LP settings, whether it be sea level or whether it be at 10,000 feet. It's one control and one display will fit the entire product line. The displays are also backwards compatible to the first generation Raptors. The first generation Phantoms, unfortunately, the Sage 2.3 control is not backwards compatible to the first gen Phantoms. So each one of these are going to have their own conversion kit. The LP conversion is a lot easier to be done before we hang the units up on the wall. The Raptor 320, 399, there'll be the top plate that you'll remove off the boiler. But the wall hung products, it's much easier to do before you hang it. There is an access panel now on the side. There's a little like 4x6 panel on the side that we can get in, that we can get into. Makes it much easier. Don't need a pen. Let me be drawing on this. The 205 and the 270 are the only ones that will have an orifice change. All the other ones will need a new venturi. These will be your throttle screw settings, and these are just light off points. These are approximate light off points, and more times than not, we're going to usually be about 1.5 turns to 2 turns past where this is when we do our final combustion setup. Often when we do the set, it's out fairly far, but they should light off there. If they don't light off at that point, again, go a full turn when we get kind of heavy-handed until it lights off. Then we dial it back in with the combustion analyzer. So this is showing a detail of how to get the gas valves apart for the 85 to 205. There's going to be a flexible gas connector here. So we technically don't have to take all of this apart. And as soon as I get some little bit nicer weather out here, I'm going to be doing a YouTube video on the LP conversion for this. So I'll be up on our YouTube page. Basically undo the screws, slide the gas valve back out of the way, and replace the Venturi, put everything back in, tighten the gas valve back up. Our conversion kit is going to come with a new O-ring, a new rubber coupling, and new screws. There is no difference between the natural gas screws and the propane screws, no difference between the natural gas O-ring and the LP O-ring. Same thing with the coupling. We give you extra pieces. This way, if something falls into an area of the basement where we can't get to it, or we drop it, we're not left holding the city end of the stick. So we're still able to keep moving forward with it. The 270 is just the orifice. We'll pop it apart, pop it off the side. We'll pop the orifice out of the gasket and pop it back in, and it's right back together. 320, 399. The Venturi looks similar to a coffee can, small little coffee can, soda can. We're going to take it all apart. You are able to get it out without fully taking this apart. We undo this nut. It'll give us enough space in here to pop this out. Again, I look at things from a service technician aspect, trying to get it done with as little effort as possible. When I was still in the field, I was lazy by nature. If I could do it with less effort, I was going to find a way to do it. We went over the selecting the altitude. Again, that video was an afterthought to this training when I couldn't come out there in person. I believe I was supposed to be out there. It was like last month was when we originally proposing it before they shut the world down. Was when I kind of had this training put together. So without being able to be there in person, start doing the videos to try and make it a little bit easier to help understand what's going on. And again, these are going to be right out of the manual. The manuals that I gave you guys in the handouts, I download them into my iBooks. I have them on my cell phone almost all of the time. Oftentimes, if you guys call me and I'm driving, I usually just give me a little bit to pull over so I can pull the manuals up for you, and I'll be able to work with you. Troubleshooting. Now, this is where this control really shines. It is very, very easy, very straightforward. Very, very straightforward. It's going to basically tell you what's going on with it. The sensor faults, it's going to either be 024, 728, or -512. All of those three numbers are basically telling you that that sensor has failed. Usually it's 024 or -512. If it says 728 degrees, it is usually shorted. Something bad happened there. But the help button will be flashing. If you press help, it'll go into active faults. It'll be soft lockout, hard lockout, limit string, and it'll kind of tell you what's going on with it. This error right here, this **00FF, that likes to reek its little head, usually after sharp power disconnects, brownouts, power outages, lightning storms. Again, this control, you're going to want to treat it kind of like you would any of the like your computer. There's 3 microprocessors inside of the that Sage control. Dirty voltage fluctuations, they're not a big fan of it. It's not a non-negotiable standard, but it is advised to protect the unit with a UPS, some sort of an uninterrupted power supply, or a surge protector. definitely, especially some of the rural areas. But this one is a communication fault, and unfortunately, it's a 50-50 shot. It's either the control stop talking to the display, or the display stop talking to the control. In some rare occasions, it's the harness is loose. In some rare occasions, the harness, especially if it happens right out of the box in shipping, the green communication harness usually just needs to be plugged back in. Our sensors are not able to be jumped out. Can't jump them. They're looking for a resistance, a constant resistance. Supply and return water temperatures are all going to be 10K. If you're metering it, I suggest meter it right from the harness. Again, one of the disadvantages to not being there in person. If you look at our wiring harnesses, one of the things that really sets us apart, all of our wiring harnesses are labeled. It's written on there what it's doing, where it's going to. There's a lot of wires stuck in there. We have a wiring harness for supply and return sensors, fan speed harnesses, so on and so on. There's a lot of some of the same colored wires. We may be telling you to test the blue and gray wire. There's 3 sets of blue and gray wires in there. So we know, we can tell you blue and gray wire that's going to say supply sensor, return sensor, and it tells you where it goes to on the board, like J2, F4 as far as the landing points. Makes troubleshooting much easier. Or we can go right through our control, and our control will kind of tell us what's going on with the sensors. We'll have sensor status, and it will tell you whether it's open, normal, what's going on with it. Usually doesn't lie. If it's not plugged in, it'll definitely be open. If you're 4 to 20 milliamp, we'll also, if you're doing remote modulation or allowing a like a TechMar or control to modulate the boiler, we'll have to set it for that, but it'll come set for none. In the manual, there will be the ohm readings for all of these sensors, what the outdoor sensor should be reading and what your supply, return, and flue sensor should be reading. Your supply sensor is also going to act as a high limit, as a manual reset high limit. It's a there's 3 connectors, 3 wires on there. It'll be red with a gray line, and gray. They're looking for the same resistance between them. It is listed that it can be a form of manual reset high limit. Your first form of manual reset high limit, if the control sees temperatures over 210 degrees, it goes into a hard lockout. In some cases, with the supply sensor, you'll get and on the screen here, it'll say unreliable. That's usually, it's out of range. It is a defective supply sensor, but that error will sometimes drive you nuts because it will come and go. And it's usually, when that shows up, it's usually around the 150 to 170 degree range is when that shows up. So, well, I said at the beginning, we were going to talk about the combi. Again, we only have one size on the combi. It's going to be 155,000 BTUs. Roughly gives us 4.5 gallons a minute at a 70 degree rise, and it takes a minimum of a half gallon a minute to operate it. The mixing valve comes included with it. The piping down here is already included with it with the mechanical flow switch. Your domestic hot water connections will be right there on the bottom. Your domestic hot water in. domestic hot water out, and then your mix leaving. It'll fit right underneath. The mixing valve is already in there, and they're all sweat connections. You can press right to it. I would suggest maybe putting unions on it so you're able to drop it down to flush it. You're going to want to treat the combi just as you would treat a tankless water heater. It's going to need to be flushed and serviced, especially based upon the water conditions, because everything that's included with it, and these are union connections here. Showing piping the combi in some cases, you will need a thermal expansion tank for the domestic hot water side. I'm not sure if your jurisdiction is one of the areas that are putting in that are requiring backflow prevention or dual check valves on the meters, in essence making the potable water system a closed system. If that's the case, you would need to put in a thermal expansion tank so the relief valve does not start doing its job. We're going to get into the Sage panel to talk about what our Sage panel can do. Give me a second and I'll pull that training up. Our Sage panel will wire just like any other zone panel, except it allows us to set the BTU rates for every single zone. So our Sage panel, again, it's going to wire like a ZVC 504 or an SR 504 from Takeo. Currently, we're the only one, no other competitor offers this. Really allows us to control the heating system, to really fine tune everything with it. So most of our heating systems now have multiple zones, with Honeywell RedLink, and if you get really creative, you can zone almost anything if you can find the supply and the returns for that zone. And with PEX and everything, it makes it where we can zone almost everything. I know when I was still in the field, I did a home just outside of Narberth, Pennsylvania. It's a older portion of the main line. Made Villanova may be a better pinpoint for it. That home had 14 zones of heat. 14 zones. It was a lot of PEX, a lot of wiring, but it had 14 zones. If we'd have had the Sage panel, then I'd not have been able to provide each room with its own temperature. I've been able to provide each room with its own BTU rate. And again, it's going to be almost identical in price to a Takeo panel. So if you're already using one and you're using our boiler, this is going to be a great add-on for you. It allows you to take complete control of that heating system. We can dial in every single zone as far as the BTU rates. It'll also allow us to run 3 different water temperatures with 2 different outdoor reset curves. I can have my domestic hot water temperature. I could have a central heating temperature with its own reset curve, and I could have an auxiliary heating set point with its own reset curve. If I was doing radiant with fan coil backups, or high temperature baseboard with panel rads, you can get really creative with it. Heat matching allows us to size for the proper load, to cut down on short cycling. In many cases, by using the Sage panel, I can pull a buffer tank out of the picture. Velocity also does now offer buffer tanks. We have a 30, a 40, I believe a 70-gallon buffer tank. Don't quote me on the last one. I know the two smaller ones. But
in a 75.
there we go. See, that's why the salesman's on here, not just the tech guy. So the panel wiring, again, it's going to be just like most third-party panels, whether it be Takeo, Argo, Honeywell. I think even Caleffi now has their own zone panels. It's going to be basically the same way. We're going to use our Cat5 cable, and it comes with the boiler with the panel. So you don't need to source one. It's approximately 25 feet, and it'll plug right in. If you were doing master slave, you would set the dip switches. If you're doing multiple panels, we can do up to 4 panels for a total of 16 zones. And they're going to wire the same. This one's showing wiring with zone valves and controlling the pumps off of it. So basically what this does, it allows the boiler to modulate within a window. Basically, okay, zone 1 is 40,000 BTUs. I have a Raptor 105. It's going to modulate from 10,500 BTUs to 40,000 BTUs will be the window that zone 1 modulates in. Zone 2 has 60,000 BTUs. So now it's 10,500 to 60,000 BTUs. It'll modulate in those windows. You can set each zone up, or you can allow it to kind of quote unquote learn it. There's a zone release feature in there where you leave all the zones set at 40,000 BTUs, it'll release and it'll allow the boiler to modulate to its full range, and it'll figure out where it needs to be over a period of time. That zone release feature is also kind of a backup where if we misjudge it, if we forget to count a room that's connected to the zone, if that zone is not satisfying or doesn't show any signs of satisfying, it'll release the BTU hold and allow the boiler to fire to its fullest firing rate. So if we're setting the heat rates, showed you the display earlier. We're gonna go into the modulation setup. Same menu where we were making the altitude changes, and there'll be this wonderful little menu that illuminates that says zone or zones. When we press that button, it'll allow us to set the heat rates for each zone, and it'll come up panel 1, 2, 3, and 4. We'll go through and dial everything in. This is actually going to be my next video that'll be up on YouTube, is doing the Sage panel, showing what each menu is and how to properly set it. But this is what it will look like. We'll have maximum expected heat rate, 80,000 BTUs. We'll click zone panel. It'll show up panel 1 through 4. We'll select panel 1. Panel 1, I can do zone 1 through 4, and I can set the firing rates for each one of those zones. Still gives you full priority. So if you have a home that has 4 zones of heat, we can use the panel for those 4 zones. The domestic hot water terminals on the boiler will still work, and always will still work. If you ever have any question whether it's hooked up to a 4 to 20 milliamp system or 0 to 10 volt DC, for some reason the boiler is not turning on or not responding, if at any point on any of the products, if you jump the DHW terminal, it will always fire for domestic hot water, unless there's an error or something seriously wrong. But it will quickly let you know whether it's an issue with the boiler or whether it's an issue with the external system. So basically, how this is going to work is it's going to find its curve as far as the BTUs of where everything needs to be. Instead of just bouncing all the way up to 100%, it'll float around and it may find that it lives happily at half firing rate. Lower firing rates result in lower fuels. You tie the Sage panel in with the outdoor reset with the outdoor reset and the high and modulating condensing boiler. We've got some real energy savings there. We can really fine tune this system and really get the most efficiency out of the system. As a lot of the times it's talking about, okay, we're putting in a 95% boiler, and in real life terms, that boiler is only 90 to 92% when it's seeing return temperatures under 120 degrees, 120, 130 degrees. If we're not using outdoor reset and we're letting this thing run to 180 degrees all day long, it's only 88% efficient. It's a very expensive 80% boiler. We'll get some benefits out of the modulation, but not the full benefits of it. So if we really fine tune that system, we can get more system efficiency, not just combustion efficiency. We can get whole system efficiency, and this is what this control allows us to do, is take control of that system. Instead of when zone 1 calls, and zone 1 may only be 20,000 BTUs, instead of it hunting up and down on its curve till that thing's satisfied, it knows 20,000 BTUs is its ceiling, and it stops there. And again, as Megan was saying, it gets the most efficiency out of that product. Any questions at all on the Sage panel? Because before we talk about venting, I always say venting for last, because venting is that touchy subject. People get very, very touchy when it comes to venting, because my opinions are not always the same as others, and our instructions are not always the same as others. So our entire condensing line is going to vent primarily the same. In the front of the I&O manual, there's going to be this wonderful little drawing of the house. And our products are not going to vent that much differently than most direct vent appliances. We need to be 1 foot away from any operating door or window. We need to be 12 inches, not 12 feet. We're 12 feet above it, might as well be on the roof. Sorry about that. 12 inches above our nominal snow line. Whatever that may be, varies from area to area. City of Philadelphia, we really haven't had snow in quite some time. What are the options when we have more than 16 zones? I can get kind of creative with that, depending on how we're doing it and what we're zoning with, Jay. I did it at the president of our company's house. I grouped some zone valve zones together and wired them into the Sage panel as a circulator, and did the single zone, did that zone panel as a single zone. Depending on how we're doing it, there's some different strategies that we can do. Counting the DHW terminal, we can do 17 zones. But we can work some things. It's kind of playing in the gray area, especially if we're doing both circulator and zone valve zoning. We can group some of the things together, because there still may be some micro zones in there. We can group, if we're doing a bunch of radiant, I can sometimes group the mud room in the kitchen and put them on one zone. Hopefully that answered it for you. So sorry about that. We'll get back to venting. Again, 12 inches above our nominal snow line. We're supposed to be 4 feet away from meters, both electric and gas, and that is due to that wonderful plume that comes out of there. All that water vapor does not play well with the electric meters, and especially some of the gas regulators. That water vapor gets inside there, gets on the regulator diaphragm, and will cause the diaphragm to pop. Our overhang clearances, if you're coming out on the eaves or over any overhangs, 12 inches out, 12 inches below, 24 inches out, 24 inches below, so on and so on. A few things to remember with it. Again, 7 foot above grade if it's adjacent to a public walkway. You don't want to install over an area where your vapor will create a condensate hazard where it will make it slippery. And we'll stay out of an inside corner of a building. The inside corners usually result in recirculation, and recirculation does some pretty nasty things to these products. Real quick way of telling that is if we pull the flame sensor and the igniter and they look kind of brick red, that's one good telltale sign of recirculation. Another one is all the hazing on the inside of the cabinet. I see a lot of your plastics will get very, very brittle. If anyone's familiar with some of the earlier condensing products, whether even our old Bimini series, if you had a lot of recirculation, these swirl plates, those plastic swirl plates would just get destroyed. It would wipe the veins right out of them. So we want to try and keep recirculation eliminated. We don't want any of it. Unfortunately, on some of the terminations, there'll be some, especially depending on low fire conditions and which way the wind's blowing, but we want to try and keep recirculation to a minimum. A few things with our products. We're going to recommend that you use 30 inches of CPVC prior to transitioning to PVC. PVC technically has no vent listing. If you were to call Charlotte Pipe and ask them for the ASTM numbers for PVC being listed as a gas vented appliance, it doesn't exist. PVC is technically not approved for venting gas appliances. It's been left up to manufacturers to do so. I would love to see everyone vent in polypropylene, but the industry's still kind of stuck on PVC. So we have a vent kit we'll go over just a little bit that includes everything you need to then transition over to PVC. We want to try and put a hanger every 4 feet, and don't penetrate the hangers with fasteners. Don't zip screw your banding iron directly to your vent pipe. We want to slope that pipe back towards the boiler. That boiler is designed to take care of all of the condensate. We want to allow that to happen. Let it deal with it. Let it pump it elsewhere. If we slope it towards the outside, we usually wind up with ice dams and nuisance lockouts on the products. We don't need to insulate the vents. We don't want to do that. And if we're using the chimney chase options, nothing else can go into that chimney. So our vent kits, what's included with them? You get 30 inches of CPVC. You get a CPVC 90. You get the screens. Wow, I did not know Charlotte Pipe was out of business. Thank you, Terry. I'll have to change my listing. I've been out of the field for 6 years, so I haven't really paid much attention. But our vent kits, what they will come with, I get your CPVC, your CPVC 90, your 2 stainless vent screens, and your terminations. There is a 2-inch option. The 85 and the 105 on the Raptor can vent in 2-inch. We can go 135 feet in 3-inch. We can go 60 feet with 2-inch. 2-inch basically going to be the same, except it's going to have the reducers and everything's going to be in 2-inch. The 320, 399, there is a 4-inch kit available for it, but they can also be vented in 3-inch, just at a reduced vent length. So our I&O manual, this is from the Raptor's I&O manual. Our venting tables can be very thick. I think it's almost 70 pages of venting. You don't need to read all 70 pages. This is showing our sidewall. If you're venting a CPVC and you're venting a 2-inch, we need to pay attention to these 3 figures. Don't need to read all 70 pages. Just glance over these, basically over 3 pages, and it'll show you how you can vent them. If you're using Duravent or Centrotherm or any of the polypropylene manufacturers, that would be the pages that you would follow. And again, minimum vent lengths are going to be 30 inches for them, and that's mostly for noise. 30 inches is going to be, if it's shorter than 30 inches, sometimes we have to figure some things out. They do get a little rowdy on initial light off, but hopefully you have at least a 30-inch vent length. Some of our options, you have snorkel that originally was only for PVC. They do have UV rated polypropylene now, so you can snorkel polypropylene. Your low profile terminations and your concentric terminations. You can use the same plane and just raise the exhaust higher than the air intakes to prevent cross contamination. This is building down in downtown Lancaster, showing all the boilers installed and multiply piped. Oh, excuse me. Our standard 2-pipe venting it, just need to have them 12 inches apart from center to center is the minimum, and above the 12 inches above the nominal snow line. Showing the low profile option or the concentric option. When I was still in the field, the concentric option was my favorite. I was fairly lazy. Again, like I said earlier, if I had to work hard, I wasn't going to. I only had to drill one hole with the concentric option as opposed to drilling two. Found the center on one and just put the hole through. Snorkel options and a vertical 2-pipe. Concentric for the vertical. Concentric works out real well on roof penetrations. Very few holes through it. We do have a B-vent chase option, where you can use the B-vent for your fresh air intake if you can get to every joint in the B-vent chimney and seal it. My stance on this is if I can get to every joint in the B-vent chimney and seal it, we wouldn't be using the B-vent chimney as a chase. But the option's there. And this is from the vent manufacturer itself that wants each joint sealed. Split options, we can go up through the roof with our exhaust and in through the sidewall with our air intake. And same thing with the chimney. Like I said, we had the chimney chase option, both flexible polypropylene, and there is a stainless steel option. With the polypropylene option, you would have to knock on the Mrs. Jones's door next door and sell her a high efficiency product as well, especially if it's a adjacent chimney. This product could no longer be used. If we're using the stainless steel option, Mrs. Jones can keep her neighbor can keep there, or if it's a home with a wood burning fireplace next to it, they can keep that there. If there is a rupture in the flue liners, if that rupture melts stainless steel, they've got bigger problems than just stainless steel melting. It's basically why if you're doing a polypropylene liner, that you can't have the adjacent chimney still being used. Even with the stainless steel liner, the boiler can be the only appliance going into that chimney. No other appliance can vent into there. So if they have a water heater, we either have to sell them a combi, do an indirect tank, or do a power vented water heater. Some of the venting don'ts. These are real life situations that I've taken pictures of. There's one in here that is fake. It's the ice one. I stole that one off the internet, but these are real life situations when I get to go out to visit jobs. Things that people have done. Right up through an old existing chimney. There's 2 boilers vented up into there. They've insulated and screwed the plastic band iron to the vent piping. There's barometric damper on the air intake. Not even sure why that's there. Again, this is the one that I stole from the internet. What happens if you don't pitch them correctly? This is my real head scratcher. This is the Philadelphia Housing Authority, and cross-contamination, a lot of things wrong here. We gave them the vent kits for the boilers, and you can see they used the CPVC first. first things that were on there. Very, very fun. But these are things that you want to try and avoid. These are all worst case scenarios. And again, venting is usually one of the first things I suggest that you look at. A lot of times it's easier to move that boiler to an outside wall or where we're closer to get that vent there than try and run the 3-inch vent line across basements or through finished areas. Usually take a look at the venting firsthand. You want to look at where you're going to be venting out on. Is it where they parked their car? Is the condensing unit for the air conditioner right outside? Is it a garden that they actually like? Is there a bush there that they're fond of? Because it might not happen right away, but again, that exhaust is going to destroy that bush. If it's where they park their car, the exhaust coming out is very acidic. Damage the paint, any of the rims, any of the issues with it, any product of the car. If it's going to be vented out on a patio and it's used for domestic hot water, there's going to be exhaust coming out of it year round, not just during the winter months. All things to take into consideration when we're looking to vent these products. And we have a lot of options with it, so we can usually figure out a place for it to go. Any more questions from anybody? Well, that is all I have for you this afternoon. I want to thank all of you for coming out. Again, if you guys have any questions at all, you can feel free to reach out to me or Lee or Jim and his team. I'm available almost 24/7. I'd say in majority of my trainings, if I'm awake, I answer. It is true. Jim has my cell number, is able to get in touch with me. Most of the guys have my email. We're here to support you and help you work through this. And again, thank you again for taking the time. Hopefully I answered any of your questions. If you have any other questions, feel free to email me about them. I'm sure you guys have it. If not, I can send them out to you guys. Actually, you'll be getting an email actually from me with the video of the webinar today and your certificate that you sat through and listened to me for an hour and so many minutes. But thank everyone for attending. Hopefully, when all the stuff's over, we get to come out and do some face-to-face. You maybe come out to our live fire training center, which is really nice and hands-on. We have all the products set up in the front of the room for you to take apart and learn on. Or I come out to you and we have our training van. I have the residential products on the training van. I have the Phantom, the Raptor, and the Phantom Combi. But again, thank you all. It's a pleasure talking with you.
Thank you, everyone.